Chapter 4, Part 2, Installing, Step by Step. 4.2.1, Booting and Starting the Installer. Once the BIOS has begun booting from the CD or CD-ROM, the ISO Linux bootloader menu appears. At this stage, the Linux kernel is not yet loaded. This menu allows you to choose the kernel to boot and enter possible parameters to be transferred to it in the process. For a standard installation, you only need to choose Install or Graphical Install with the arrow keys, and then press the Enter key to initiate the remainder of the installation process. If the DVD-ROM is a multi-arch disk and the machine has an Intel or AMD 64 processor, those menu options enable installation of the 64-bit variant, AMD 64, and the installation of the 32-bit variant remains available in a dedicated submenu, 32-bit install options. You will have a 32-bit. If you have a 32-bit processor, then you don't get a choice, and the menu enters install the 32-bit variant. Going further, 32 or 64 bits. The fundamental difference between a 32 and 64-bit systems is the size of memory addresses. In theory, a 32-bit system cannot work with more than 4 gigabytes of RAM. In practice, it is possible to work with around this limitation by using the 686-PAE kernel variant, so long as the processor handles the PAE physical address extension functionality. Using it does not have a notable influence on system performance. However, this is why it is useful to use the 64-bit mode on a server with large amount of RAM. For an office computer, where a few percent difference in performance is negligible, you must keep in mind that some proprietary programs are not available in 64-bit versions. It is technically possible to make them work on 64-bit systems, but you have to install the 32-bit versions of all the necessary libraries. See section 5.4.5 multi-arch support. And sometimes to use the setarch or Linux 32 in the util Linux package to trick the application regarding the nature of the system. In practice, installation alongside an existing Windows system. If the computer is already running Windows, it is not necessary to delete the system in order to install Debian. You can have both systems at once, in each installed on a separate disk or partition, and choose which to start when booting the computer. This configuration is often called dual boot, and the Debian installation system can set it up. This is done during the hard drive partitioning stage of installation and while setting up the bootloader. See the sidebars in practice, shrinking a Windows partition, and beware bootloaders and dual boot. If you already have a working Windows system, you can even avoid using a CD-ROM. Debian offers a Windows program that will download a light Debian installer and set it up on the hard disk. You then only need to reboot the computer and choose between normal Windows boot or boot in the installation program. You can also find it on a dedicated website with a rather explicit title. Huh. So you can even avoid using a CD-ROM or a USB then. You set it up on the hard disk and reboot and choose. You can do that with another Linux distribution as well. Back to basics, bootloader. The bootloader is a low-level program responsible for booting the Linux kernel just after the BIOS processes off its control. To handle this task, it must be able to locate the Linux kernel to boot on the disk. On the i386 and AMD 64 architectures, the two most used programs to perform this task are Lilo, the older of the two, and Grub, its modern replacement. ISO Linux and Sys Linux are alternatives frequently used to boot from removable media. Each menu entry hides a specific boot command line, which can be configured as needed by pressing the Tab key before validating the entry and booting. The Help menu entry displays the old command line interface, where the F1 to FT keys display different help screens detailing the various options available at the prompt. You will rarely need to use this option except in very specific cases. The Expert mode, accessible in the Advanced Options menu, details all possible options in the process of installation and allows navigation between various steps without them happening automatically in sequence. Be careful, this very verbose mode can be confusing due to the multitude of configuration choices that it offers. The rescue mode, also accessible in the advanced options menu, allows to recover a broken system or fix the bootloader. After presenting the first few screens of the installer, it will allow to enter a shell prompt in the file system you selected to perform any necessary actions or allow to reinstall the bootloader. Once booted, the installation program guides you step by step through the process. This section presents each of these steps in detail. You will follow the process of an installation from an AMD64 DVD-ROM, more specifically the RC3 version of the installer for Bullseye. NetInst installations, as well as the final release of the installer, may look slightly different. We will also address installation in graphical mode, but the only difference from classic, that is text mode, installation is the visual appearance. Selecting the language. The installation program begins in English, but the first step allows the users to choose the language that will be used in the rest of the process. Choosing French, for example, will provide an installation entirely translated into French and a system configured in French as a result. This choice is also used to define more relevant choices, default choices in subsequent stages, notably the keyboard layout. Back to basics. Navigating with a keyboard. Some steps in the installation process require you to enter information. These screens have several areas that may have focus. Text entry area, checkboxes, and list of choices, OK, and cancel buttons. And the tab key allows you to move from one to the other. In graphical mode, you can use the mouse as you would normally do on an installed graphical desktop. Let's have a look. Selecting the country. The second step consists in choosing your country. Combined with the language, this information enables the program to offer the most appropriate keyboard layout. This will also influence the configuration of the time zone. In the United States, a standard QWERTY keyboard is suggested, and a choice of appropriate time zones is offered. Selecting the keyboard layout. The proposed American English keyboard corresponds to the usual QWERTY keyboard. Detecting hardware. This step is completely automatic in the vast majority of cases. The installer detects your hardware and tries to identify the CD-ROM drive used in order to access its content. It loads the modules corresponding to the various hardware components detected and then mounts the CD-ROM in order to read it. The previous steps were completely contained in the boot image included in the CD, a file of limited size and loaded into memory by the BIOS when booting from the CD. The installer can work with the vast majority of drives, especially the standard ATA-P peripherals, sometimes called IDE or an eIDE. However, if detection of the CD-ROM reader fails, the installer offers the choice to load a kernel module, for instance from a USB key, corresponding to the CD-ROM driver. 4.2.6 Loading components. With the contents of the CD now available, the installer loads all the files necessary to continue with its work. This includes additional drivers for the remaining hardware, especially the network card, as well as the components of the installation program. Detecting network hardware. This automatic step tries to identify the network card and load the corresponding module. If automatic detection fails, you can manually select the module to load. If no module works, it is possible to load a specific module from a removable device. This last solution is usually only needed if the appropriate driver is not included in the standard Linux kernel, but available elsewhere, such as the manufacturer's website or in firmware archives/pages. These steps must absolutely be successful for NetInst installations, since the Debian packages must be loaded from the network. Configuring the network. In order to automate the process as much as possible, the installer attempts an automatic network configuration by DHCP for IPv4 and by IPv6 network discovery. If this fails, it offers more choices. Try again with normal DHCP configuration. Attempt DHCP configuration by declaring the name of the machine or set up a static network configuration. The last option requires an IP address, a subnet mask, an IP address for a potential gateway, a machine name, and a domain name. Tip: configuration without DHCP. DHCP. If the local network is equipped with a DHCP server that you do not wish to use because you prefer to define a static IP address for the machine during installation, you can add the netconfig slash use underscore DHCP equals false option when booting from the installation media. You just need to go on to the desired menu entry by pressing the tab key and add the desired option before pressing the enter key. Beware, do not improvise. Many local area networks are based on an implicit assumption that all machines can be trusted, and inadequate configuration of a single computer will often perturb the whole network. As such, do not connect your machine to a network without first agreeing with its administrator on the appropriate settings, for example, the IP address, netmask, and broadcast address. Administer the password. The super user root account reserved for the machine's administrator is automatically created during installation. This is why a password is requested. The installer also asks for a confirmation of the password to prevent any input error, which would later be difficult to amend. Note that you can leave both fields empty if you want the root account to be disabled. In that case, the login for the root user will be deactivated, and the first regular user that will be created by the installer in the next step will have administrative rights through sudo. The sub-user root account reserved for machine administrator is automatically created during installation. This is why a password is created, because the installer also asks for confirmation of the password to prevent any input error, which would later be difficult to amend. Note that you can leave both fields empty if you want the root account to be disabled. In that case, the login for the root user will be deactivated, and the first regular user will have administrative rights through sudo. Right. Security. Administer password. Root user password should be long, 12 characters or more, and impossible to guess. Indeed, any computer, and a fortiori any server connected to the internet is regularly targeted by automated connection attempts with the most obvious passwords. Sometimes it may even be subject to dictionary attacks in which many combinations of words and numbers are tested as passwords. Avoid using the names of children or parents, dates of birth, etc. Many of your coworkers might know them, and you rarely want to give them free access to the computer in question. These remarks are equally applicable for other user passwords, but the consequences of a compromised account are less drastic for users without administrative rights. If inspiration is lacking, do not hesitate to use password generators such as PWGN in the package of the same name. Creating the first user. Debian also imposes the creation of a standard user account so that the user administrator doesn't get into the bad habit uh, of working as root. The precautionary principle essentially means that each task is performed with a minimum required writes in order to limit the damage caused by human error. This is why the installer will ask for the complete name of its first user, the username, and their password twice to prevent the risk of erroneous input. Configuring the clock. Um, if the network is available, the system's internal clock is updated in a one-shot way from an NTP server. This way, the timestamps on logs will be correct from the first boot. For them to remain consistently precise over time, an NTP daemon needs to be set upper initial installation. See section 8.9.2 time synchronization. Detecting disk and other devices. This step automatically detects the hard drives on which Debian might be installed. They will be presented in the next step, partition. Starting the partitioning tool. Partitioning, an indispensable step in installation, consists in dividing the available space on the hard drives, each subdivision thereof being called partition, according to the data to be stored on it and the use for which the computer is intended. This step also includes choosing the file system to be used. All of these decisions will have an influence on performance, data security, and the administration of the server. The partitioning step is traditionally difficult for new users. It is necessary to define the various partitions of the disks or partitions on which the Linux file systems and virtual memory swap will be stored. Virtual memory is the swap. This task is complicated if another operating system that you want to keep is already on the machine. Indeed, you will then have to make sure that you do not alter its partitions or that you resize them without causing damage. Fortunately, the partitioning software has guided mode which recommends partitions for the user to make. In most cases, you can simply validate the software's suggestions. Next, continue. The first screen in the partitioning tools offers the choice of using an entire hard drive to create various partitions. For a new computer which will solely use Linux, this option is clearly the simplest, and you can use the option guided, use entire disk. For the computer has two hard drives for two operating systems. If the computer has two hard drives for two operating systems, setting one drive for each is also a solution that can facilitate partitioning. In both of these cases, the next screen offers to choose the disk where Linux will be installed by selecting the corresponding entry. For example, SCSI1 000 SDA 53 hard disk, and then start guided partitioning. Guided partitioning can also be set up LVM logical volumes instead of partitions, see below. Since the remainder of operation is the same, we will not go over the option guided use entire disk and set up LVM encrypted or not. In other cases, when Linux must work alongside other already existing partitions, you need to choose manual partitioning. The guided partitioning tools offer three partitioning methods which correspond to different usages. The first method is called all the files in one partition. The entire Linux system tree is stored in a single file system corresponding to the root, that is slash directory. The simple and robust partitioning fits perfectly for personal or single-user systems. In fact, two partitions will be created. The first will house the complete system, and the second is the virtual memory, the swap. Second method, separate home partition, is similar, but it splits the file hierarchy into two. One partition contains the Linux system, root, and the second contains home directories, meaning user data in files and subdirectories available under /home. The last partitioning method, called separate home var and temp partitions, is appropriate for servers and multi-user systems. It divides the file tree into many partitions. In addition to the root and user accounts, it also has partition for server software data, var, and temporary files, temp. These divisions will have several advantages. User cannot lock up the server by consuming all available hard drive space. They can only fill up temp and home. And the daemon data, especially logs, can no longer clog up the rest of the system. Back to basics. Choosing a file system. A file system defines the way in which data is organized on the hard drive. Each existing file system has its own merits and limitations. Some are more robust, others more effective. If you know your needs well, choosing the most appropriate file system is possible. Various comparisons have already been made. It seems that RiserFS is particularly efficient for reading many small files. XFS in turn works faster with large files. X4, the default file system for Debian, is a good compromise based on the three previous versions of file systems historically used in Linux: X, X2, and X3. X4 overcomes certain limitations of X3 and is particularly appropriate for very large capacity hard drives. Another option would be experiment with the very promising BTRFS, which include numerous features that require to this day the use of LVM and or RAID. A generalized file system such as X3, X4, BTRFS, RISERF, or XFS takes special measures to make it possible to return to a priori consistent state after an abrupt interruption without completely analyzing the entire disk, as was the case with the X2 file system. This functionality is carried out by filling in a journal that describes the operations to conduct prior to actually executing them. If an operation is interrupted, it will be possible to replay it from the journal. Conversely, if an interruption occurs during an update of the journal, the last requested change is simply ignored. The data being written could be lost, but since the data on the disk has not changed, they have remained coherent. This is nothing more nor less than a transactional mechanism applied to the file system. After choosing the type of partition, the software calculates a suggestion and describes it on the screen. The user can then modify it if needed. You can, in particular, choose another file system if the standard choice, ext4, isn't appropriate. In most cases, however, the proposed partitioning is reasonable and it can be accepted by selecting the Finish Partitioning and write changes to disk entry. Manual partitioning. Manual partitioning allows greater flexibility, allowing the user to choose the purpose and size of each partition. Furthermore, this mode is unavoidable if you wish to use software RAID. In practice, shrinking a Windows partition. To install Debian alongside an existing operating system, Windows or other, you must have some available hard drive space that is not being used by the other file system in order to be able to create the partitions dedicated to Debian. In most cases, this means shrinking a Windows partition and reusing the free space. The Debian installer allows this operation when using the manual mode of partitioning. You only need to choose the Windows partition and enter its new size. This works in the same with both an encrypted FAT and NTF partition. If Windows is using BitLocker encrypted partition, the steps to resize them require to use the BitLocker management tool together with the Windows Disk Management tool. The first screen displays the available disks, their partitions, and any possible free space that has not been partitioned yet. You can select each displayed element. Pressing the Enter key then gives a list of possible actions. You can erase all partitions on a disk by selecting it. When selecting free disk and free space on a disk, you can manually create a new partition. You can also do this with guided partitioning, which is an interesting solution for a disk that already contains another operating system, but which you may wish to partition for Linux in a standard manner. See section 4.2.13.1 Guided Partitioning for more details on guided partitioning. Did we just read it? We just read that. Yeah. Back to basics. Mount point. The mount point is the directory tree that will house the content of the file systems on the selected partition. Thus, a partition mounted at /home is partitionally intended to contain user data. When this directory is named /, it is known as the root of the file tree, and therefore the root of the partition that would actually host the Debian system. Back to basics. Virtual memory swap. Virtual memory allows the Linux kernel, when lacking sufficient memory RAM, to free a bit of memory by storing the parts of the RAM that have been inactive for some time on the swap partition of the hard disk. It is also fundamental to the suspend and hibernate features of a system. To simulate the additional memory, Windows uses a swap file that is directly contained in a file system. Conversely, the Linux uses a partition dedicated to this purpose, hence the term swap partition, but it is also able to use a swap file as well. When choosing a partition, you can indicate the manner in which you're going to use it. Format it and include it in the file should be using a mount point, use it as a swap partition, make it into a physical volume for encryption to protect the confidentiality of data on certain partitions, see below. Make it a physical volume for LVM. This concept is discussed in greater detail later in this chapter. Use an array device, see latest in this chapter. You can also choose not to use it and therefore leave it unchanged. 4.2.13.3 Configuring multi-disk devices. Software RAID. Some types of RAID allow the duplication of information stored on hard drives to prevent data loss in the event of a hardware problem affecting one of them. Level 1 RAID keeps a simple identical copy mirror of a hard drive on another drive, while level 5 or 6 RAID splits redundant data of a several disk, thus allowing the complete reconstruction of a failing drive. We will only describe level 1 RAID, which is the simplest to implement. The first step involves creating two partitions of identical size located on two different hard drives and to label them physical volume for RAID. You must then choose Configure Software RAID in the partitioning tool to combine these two partitions into a new virtual disk and select Create MD Device in the configuration screen. You then need to answer a series of questions about this new device. The first question asks about the RAID level to use, which in our case will be RAID 1. The second question asks about the number of active devices, 2 in our case, which is the number of partitions that is needed to include in this MD device. The third question is about the number of spare devices, 0. We have not planned any additional disks to take over for a possible defective disk. The last question requires you to choose the partitions for the RAID device. These will be the two that we have set aside for this purpose. Make sure you only select partitions that are explicitly mentioned as RAID. Back to the main menu. New virtual RAID disk appears. The disk is presented with a single partition, which cannot be deleted, but whose use we can choose, just like for any other partition. For further details on RAID functions, please refer to section 12.1.1 Software RAID. Configuring the Logical Volume Manager, the LVM. LVM allows you to create a virtual partition that span over several disks. The benefits are twofold. The size of the partitions are no longer limited by individual disks, but by their cumulative volume, and you can resize existing partitions at any time, possibly after adding an additional disk when needed. LVM uses a particular terminology. A virtual partition is a logical volume, which is part of a volume group or an association of several physical volumes. Each of these terms, in fact, corresponds to a real partition or a software RAID device. This technique works in a very simple way. Each volume, whether physical or logical, is split into blocks of the same size, which are made to correspond by LVM. The addition of a new disk will cause the creation of a new physical volume, and these new blocks can be associated to any volume group. All of the partitions in the volume group that is thus expanded will have additional space into which they can extend. The partitioning tool configures LVM in several steps. First, you must create on the existing disk the partition that will be physical volumes for LVM. To activate LVM, you need to choose Configure the Logical Volume Manager. Then, on the same configuration screen, create a volume group to which you will associate the existing physical volumes. Finally, you can create logical volumes within this volume group. Note that the automatic partitioning system can perform all these steps automatically. In the partitioning menu, each physical volume will appear as a disk with a single partition which cannot be deleted, but that you can use as desired. The usage of LVM is described in further detail in section 12. Setting up encrypted partitions to guarantee the confidentiality of your data. For instance, in the event of the loss of or theft of your computer or hard drive, it is possible to encrypt the data on some partitions. This feature can be added underneath any file system, since, as for LVM, Linux, and more particularly the dmcrypt driver, uses the device mapper to create a virtual partition whose content is protected based on an underlying partition that will store the data in an encrypted form, thanks to LUKS, Linux Unified Key Setup, LUKS, a standard format that enables the storage of encrypted data as well as meta information that indicates the encryption algorithm's use. Security. Encrypted swap partition. When an encrypted partition is used, the encryption key is stored in memory, RAM. Since retrieving this key allows the decryption of data, it is of utmost importance to avoid leaving a copy of this key that would be accessible to the possible thief of the computer or hard drive, or to a maintenance technician. This is, however, something that can easily occur with a laptop, since when hibernating the contents of RAM is stored in the swap partition. If this partition isn't encrypted, the thief may access the key and use it to decrypt the data from the encrypted partitions. This is why, when you use encrypted partitions, it is imperative to also encrypt the swap partition. The Debian installer would warn the user if they try to make an encrypted partition while the swap partition isn't encrypted. To create an encrypted partition, you must first assign an available partition for this purpose. To do so, select the partition and indicate that it is to be used as a physical volume for encryption. After partitioning the disk containing the physical volume to be made, choosing Configure Encrypted Volumes, the software will then propose to initialize the physical volume with random data, making the localization of the real data more difficult, and will ask you to enter an encryption passphrase, which you will have to enter every time you boot your computer in order to access the content of the encrypted partition. Once this step has been completed and you have returned to the partitioning tool menu A new partition will be available in an encrypted volume, which you can then configure just like any other partition. In most cases, this partition is used as a physical volume for all LVM so as to protect several partitions, LVM logical volumes, with the same encryption key, including the swap partition. See sidebar Security Encrypted Swap Partitions. We just read that. Installing the base system. This step, which doesn't require any user interaction, installs the Debian-based system packages. This includes the dpackage and app tools, which manage Debian packages as well as the utilities necessary to boot the system and start using it. Configuring the package manager app. In order to install additional software, app needs to be configured and told where to find Debian packages. This step is as automated as possible. Note: see Debian CD-ROM in the drive. If the installer detects a Debian installation disk in the CD-DVD reader, it is not necessary to configure app to go looking for packages on the network. App is automatically configured to read packages from a removable media drive. If the disk is part of a set, the software will offer to explore other disks in order to reference all of the packages stored in them. If getting packages from the network is requested, the installer allows to choose a server from which to download these packages by choosing first a country, then a mirror available in that country. A mirror is a public server hosting copies of all the files of the Debian master archive. Finally, the program proposes to use an HTTP proxy. If there is no proxy, internet access will be direct. If you type http://proxy.falco.com :3128, apt will use the Falco proxy cache, a SQUID program. You can find this setting by checking the configurations of a web browser on another machine connected to the same network. Huh? What? Okay, I mean, if you have a proxy, you can enter it. The files packages .xz and sources .xz are then automatically downloaded to update the list of packages recognized by apt. Back to basics, HTTP proxy. An HTTP proxy is a server that forwards an HTTP request for internet users. It sometimes helps to speed up downloads by keeping a copy of files that have been transferred through it. When we then speak of proxy cache. In some of these cases, it is the only means of accessing an external web server. In such cases, it is essential to answer the corresponding question during installation for the program to be able to download the Debian packages through it. Squid is the name of the server software used by Falco Corp to offer this service. Debian Package Popularity Contest. The Debian system contains a package called Popularity Contest, whose purpose is to compile package users statistics. Each week, this program collects information on the packages installed and those used recently, and anonymously sends this information to the Debian project servers. The project can then use this information to determine the relative importance of each package, which influences the priority that will be granted to them. In particular, the most popular packages will be included in the installation CD-ROM, which will facilitate their access for users who do not wish to download them or purchase a complete set. The package is only activated on demand out of respect for the confidentiality of users' usage. Okay, so it's not on by default. Selecting packages for installation. The following steps allows you to choose the purpose of the machine in very broad terms. The 12 suggested tasks correspond to list of packages to be installed. The list of the packages that will actually be installed will be fine-tuned and completed later on, but this provides a good starting point in a simple manner. This step can require a full set of installation media or an internet connection and a working mirror setup as described above. Some packages are also automatically installed according to the hardware detected, thanks to the program discover package install from the discover package. 4.2.18 Installing the grub bootloader. The bootloader is the first program started by the BIOS. The program loads the Linux kernel into memory and executes it. It often offers a menu that allows the user to choose the kernel to load and or the operating system to boot. Beware, bootloader and dual boot. This phase in the Debian installation process detects the operating systems that are already installed on a computer and automatically adds corresponding entries in the boot menu, but not all installation programs do this. In particular, if you install or reinstall Windows thereafter, the bootloader will be erased. Debian will be still on the hard drive, but will no longer be accessible from the boot menu, except for Windows 10, where it will still be accessible through the Windows Recovery Console. You will then have to boot the Debian installation system in rescue mode to set up a less exclusive bootloader. This operation is described in detail in the installation manual. By default, the menu proposed by grub contains all the installed Linux kernels as well as any other operating systems that were detected. This is why you should accept the offer to install it in the master boot record. Since keeping older kernel versions preserves the ability to boot the same system if the most recently installed kernel is defective or poorly adapted to the hardware. It often makes sense to keep a few older kernels versions installed. Grub is the default bootloader installed by Debian thanks to its technical superiority. It works with most file systems and therefore doesn't require an update after each installation of a new kernel, since it reads its configuration during boot and finds the exact position of the new kernel. Version 1 of Grub, now known as Grub Legacy, couldn't handle all combinations of LBM and software RAID. Version 2, installed by default, is more complete. While there may be still situations where it's preferable to install Lilo, another bootloader, the Debian installer does not longer support the installation of it. It's worth noting that Grub is not a single bootloader, it is more like a collection of bootloaders suited for different cases. The numerous binary packages built out of the grub source package reflect that grub-efi-amd64 is for 64-bit PC booting in UEFI mode. Grub-efi-i832 is for 32-bit PC bootloading in UEFI mode. Grub PC is for PC booting in BIOS mode, and Grub U-boot for ARM computers, etc. For more information configuring Grub, please refer to section 882, Grub 2 configuration. Culture. Secure Boot and the shim bootloader. Secure Boot is a technology ensuring that you run only software validated by your operating system's vendor. To accomplish this, at the deepest level, the UEFI firmware embeds cryptographic keys provided by Microsoft to check the bootloader signature, ensuring that it's safe to execute. Since getting a binary signed by Microsoft is a lengthy process, Debian decided not to sign Grub directly. Instead, it uses an intermediary bootloader called shim, which almost never needs to change, and whose only role is to check Debian's provided signature on Grub and execute Grub. To run Debian on a machine having secure boot enabled, the shim signed package must be installed. Down the stack, Grub will do a similar check with the kernel, and then the kernel might also check signatures on modules that get loaded. The kernel might also forbid some operation that could alter the integrity of the system. Debian 10 Buster was the first release supporting secure boot. Before, you had to disable that feature in the system setups screen offered by the BIOS or the UEFI. Finishing the installation and rebooting. The installation is now complete. The program invites you to remove the CD-ROM from the reloader and restart the computer. End of chapter 4, part 2.